Hello friends, myself R.D. Mahajan presenting my video on linear differential equation, second type of differential equation. Let us define it. An equation is said to be linear if dependent variable and its differential coefficient are in first degree. The meaning of word linear is whose degree is 1, that term is called as a linear term. Therefore, dependent variable and its differential coefficients are in first degree and not multiplied together. Then, if these two conditions are satisfied, then that equation is said to be linear differential equation. Its general form is dy by dx plus p into y is equals to q. Here, y is a dependent variable, x is independent variable. Therefore, the degree of y is 1. Its differential coefficient is dy by dx, whose degree is also 1. Therefore, the first condition is true. And it is not multiplied together. Whatever we simplify, we are not getting the term of y into dy by dx. Means second condition is also true. And as both the conditions are satisfied, that differential equation is said to be a linear differential equation. Therefore, remember this general form, where that capital P and capital Q are function of x, independent variable x, or constant. Or we have second form, if x is dependent variable and y is independent, then it is dx by dy plus p into x is equals to q. Therefore, dependent variable here x, degree of x is 1, its differential coefficient is dx by dy, its degree is also 1, means first condition is true, dependent variable and its differential coefficient with degree 1 and not multiplied together, means we are not getting the term of x into dx by dy, whatever the simplification we perform. And as both the conditions are satisfied here, the differential equation is said to be a linear. And after deciding that it is a linear differential equation, next step is we require to find multiplying factor, which we are calling as integrating factor. For the first case, that integrating factor is given by e raised to integration of p with respect to x, or for the second case, integrating factor is obtained by or given by e raised to integration of p and its integration with respect to independent variable y. Means either by this or by this we can determine that integrating factor, which we are calling as multiplying factor. And then solution is given by dependent variable multiplied by integrating factor if is equal to constant of integration capital A or C, whatever you want you can use it, plus integration of q into if or integrating factor, then either integrate it with respect to x or with respect to y. Means for the first case we have to integrate it with respect to x, for the second case we have to integrate it with respect to y. Therefore, this is the formula by which we can find the solution of that linear differential equation. And to explain it, I will discuss two simple examples of a linear type. First example, solve dy by dx plus 2y equal to x. We don't know its type, whether it is exact or whether it is linear or whether it is reducible to linear. Whenever we have to solve any differential equation, first always we check for exact. Means first we rewrite it in the form of m dx plus n dy equals to 0. And all this work we have to perform in rough. Therefore, transferring this to other side, we get dy by dx is equal to x minus 2y. Then cross multiplying it, we get x minus 2y dx. Transferring to that side, we get minus dy equals to 0. Then comparing with m dx plus n dy equals to 0, here we get m is equal to x minus 2y, n is equals to coefficient of dy minus 1. Then differentiating m with respect to y, keeping x constant, therefore its derivative is minus 2. Differentiating n with respect to x, n is constant term, therefore its derivative with respect to x is 0. And check whether the values are equal or not. Here dou m by dou y is not equals to dou n by dou x. And therefore equation is not exact. And as it is not exact, we have to think for some new technique. And therefore the next one we go for a linear differential equation. Check it whether that differential equation is linear. dy by dx, first order, first degree differential equation. Y is a dependent variable, x is independent. Then as per definition, we have to see the degree of that dependent variable. Here the degree of y is 1 and its differential coefficient dy by dx, its degree is also 1, means first condition is true, and not multiplied together. We are not getting the term of y into dy by dx. Therefore, as it is first example, I will write all that step. Dependent variable y and its differential coefficient is of degree 1 and not multiplied together. Means given differential equation satisfy that definition, and as it satisfies that definition, equation is a linear differential equation. Given differential equation is linear differential equation, and it is linear with y as a dependent, therefore linear in y. Linear in y means y as a dependent variable. And then comparing with the general form is dy by dx plus py equals to q. Comparing with this general form, we get p coefficient of y, therefore coefficient of y is here 2. We get the value of p as 2, constant term. Q right hand side term, it is x, function of x. After getting p and q, next step is we require to find integrating factor. It is given by e raised to integration of p with respect to x. Therefore, it is e raised to integration of 2 with respect to x, and therefore we get 2 constant outside. Integration of dx is x. Therefore, we get that integrating factor is e raised to 2x, which we are calling as a multiplying factor. Then the solution is given by dependent variable into integrating factor is equals to constant of integration plus integration of q into if, and then its integration with respect to x. Here the dependent variable is here y. Integrating factor we are getting as e raised to 2x is equals to constant of integration e plus integration of q x e raised to 2x, if is e raised to 2x into dx. Product of two terms of x, and to integrate it we have to apply integration by generalized part, which I will explain here. U must be the first term and v as the second term. First term, integration of the second minus derivative of the first, next integration of this plus next derivative of it, next integration of it minus next derivative and next integration of second term, and so on. Terms alternately positive negative, where suffix stands for integration. And dash represents derivatives. And to decide the order, we use this same rule, L I A T E. L stands for logarithmic, I stands for inverse, A stands for algebraic, T stands for trigonometric, and E stands for exponential. As per this, we decide the order. Therefore, here the first term x is of algebraic type, and second term e raised to 2x, it is exponential type. Therefore, algebraic comes first. Therefore, this must be the first function and e raised to 2x as the second function. And then applying this integrating by generalized part. We get left hand side as it is, no change, it is y e raised to 2x is equal to a as it is plus performing the integration of this term by generalized part. First term as it is v1 means the integration of e raised to 2x. Therefore, integration of e raised to 2x is e raised to 2x by 2, then minus derivative of first term, derivative of x with respect to x is 1. Next integration of this, therefore its integration is e raised to 2x by 2, and that previous to it becomes e raised to 2x by 4. Next plus next derivative of this term, as we have here constant term, its derivative is 0, and therefore we stop here. And this is the required solution. We can take e raised to 2x common from this. It is y e raised to 2x is equal to a plus e raised to 2x, we can take common, x by 2 minus 1 by 4 as the required solution. Therefore, in this way we can solve a linear differential equation. Second, solve y into dx by dy minus x is equal to 2y cube. Nowhere its type is mentioned, therefore we had to identify its type. Therefore, first of all, I will check for exact. If it is exact, we apply the respective technique or the corresponding technique. If it is not exact, then we go for a linear, and always perform like this. Therefore, transferring this to, and this work you can perform in rough. Therefore, y dx is equal to 2y cube plus x. Then cross multiplying, we get y dx is equal to 2y cube plus x into dy. Then transferring this to left, we get y dx minus in bracket 2y cube plus x into dy equal to 0. Comparing with m dx plus n dy, we get m is equals to y. Its derivative with respect to y is 1. We get value of n as minus 2y cube plus x. Is differentiation with respect to x. Y is constant, its derivative is 0. Derivative of x with respect to x is 1, but with minus sign, therefore minus 1. And as these two values are not equal, dou m by dou y is not equal to dou n by dou x. Equation is not exact. And as it is not exact, we have to think for our next type, that is a linear differential equation. Y into dx by dy. Therefore, dx by dy is the differential coefficient. Means x is dependent variable, y is independent. Then we have to check whether dependent variable and differential coefficients are in degree 1. Yes, here the degree of x is 1, degree of dx by dy is also 1, means it is a linear in x. Only we have to make the coefficient of that term as 1. Therefore, dividing by y throughout, we get it is dx by dy minus 1 by y into x is equal to 2y cube divided by y. Means what we have? Dx by dy minus 1 by y into x is equal to 2y square. x is dependent, y is independent, degree of x is 1, degree of dx by dy is also 1, means first condition is true, and not multiplied together, we are not getting the term of x into dx by dy, therefore it is linear. Equation 1 is linear differential equation in x. In x means with x as a dependent variable, and then comparing with general form dx by dy plus p into x is equals to q. Coefficient of x is p, coefficient of x here, therefore we get p as minus 1 by y. Q value on the right hand side 2y square. Here both p and q are functions of y, independent variable y. And then next step, we require to find integrating factor. It is given by e raised to integration of p with respect to independent variable y, and therefore it is e raised to minus integration of 1 by y dy, and it is equals to e raised to minus integration of 1 by y is log y, it is equals to this power, that minus we can take as a power as per the laws of logarithm, therefore e raised to log y raised to minus 1, e and log get cancelled, we get integrating factor as y raised to minus 1, means transferring it to denominator we get it as 1 by y. And then solution is given by dependent variable into integrating factor is equal to constant plus q into if and its integration with respect to y. Here dependent variable here is x, integrating factor is 1 by y is equal to constant of integration e plus integration of q into if, the value of q is here 2y square into 1 by y and its integration with respect to y, and therefore it is e, 2 constant we can take it outside, integration of y square by y means y remains, its integration with respect to y, and therefore we get it is a plus 2 y square by 2, and therefore that required solution is x by y is equal to constant a plus 2 to get cancelled y square is the required solution. Therefore, I have taken one example of both the type. First example when y is a dependent variable. Second example when x is the dependent variable. Some more I will discuss in my next video. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates or new videos. Thank you very much.